Okay. Last lecture, people, we completed hydrogen spectrum. We learned about the different series present in hydrogen spectrum. So before we move on to do numericals, let's quickly take a 2-minute recap. What was the formula for wave number of hydrogen spectrum? 1 over 1 by lambda is equal to RH into Z square, 1 upon N1 square minus 1 upon N2 squared. What is RH, people, over here? Rydberg's constant. And value क्या था Rydberg's constant का? 109677 centimeter inverse, or in terms of meters it is 1.1 into 10 raised to 7. ठीक है, आगे यहाँ पे एक छोटा सा नोट है. व्हाट डू वी हैव टू रिमेंबर पीपल? n1 will always be less than n2. फॉर ऑल द सीरीज हमने n1 का वैल्यू लिख के रखा है. n2 will be the transition to n1. ठीक है. सो फॉर एग्जाम्पल फॉर लीमन n2 का क्या क्या वैल्यू हो सकता है पीपल? व्हाट कैन बी द डिफरेंट वैल्यूज? n2 कैन बी 2, 3, 4 and so on. For Balmer, people, 3, 4, 5 and so on. For Pashkin it was 4, 5, 6 and so on. Bracket के लिए क्या था? 5, 6, 7 and so on. 6, 7, 8, so on and so forth. Out of the transitions, Lehman belongs to which series? UV. Balmer, visible, and Pashkin bracket and fund belong to infrared to deep infra. ठीक है. Then ये दो point people याद रखना है, that whenever we have to calculate the shortest wavelength or the wavelength for last line, what will the value be for N2? N2 will be infinity. And when we have to calculate longest wavelength, minimum energy or first line, N2 की value क्या होगी? N2 will be N1 plus 1. Lastly, to calculate number of spectral lines for any transition, how many spectral lines will be generated? उसका formula क्या है everyone? N2 minus N1 into N2 minus N1 plus 1 over 2. ठीक है. चलो, let's start with the first sum. क्या बोला यहाँ पे? Calculate the longest wavelength of hydrogen atom in the Lehman series. So first of all, कौन सा series दिया people? Lehman. If you think you can do it, आप continue कर सकते हैं. Others, pay attention. What is the value of N1 for Lehman series? 1. Now we are looking for longest wavelength. अभी हमने क्या point लिखा था? If we are looking for longest wavelength, N2 will become N1 plus 1. So N2 will be N1 plus 1. So N2 की value is what over here people? 2. 1 plus 1. Then what is the value of RH? 1.1 into 10 raised to 7 meter inverse. It is for hydrogen atom, so Z की value क्या होगी? 1. Let's substitute that in the formula. So we know that 1 upon lambda is equal to RH into Z square, 1 upon N1 square minus 1 upon N2 square. So 1 upon lambda will be 1.1 into 10 to power 7 into Z square, means 1 square into 1 upon 1 squared minus 1 upon 2 squared. Solve this for me and give me the value for lambda. I'm also doing it on the board. आप cross verify कर सकते हैं. So the answer for the first question will be somewhere approximately around 1200 angstrom. Let's continue with the next question. The next question says, calculate the shortest wavelength of Paschen series for Li plus 2 ion. Since the series mentioned is Paschen series, what will the value be for N1? We can see that Lehman, Balmer, then Paschen. N1 will be 3. Now we have to look for the shortest wavelength. N2 for shortest wavelength will be infinity. Okay. Since it is lithium ion, so Z का value क्या हो जाएगा people? 3. And we know that again RH is equal to 1.1 into 10 raised to 7 meter inverse. Therefore, we apply the formula 1 upon lambda is equal to RH into Z squared 1 upon N1 squared minus 1 upon N2 squared. RH is 1.1 into 10 raised to 7 into Z is 3 because it is for lithium, so 3 squared 1 upon 3 squared minus 1 upon infinity squared. So can someone tell me what is 1 upon infinity? Infinity square is infinity, that will be 0. Excellent. So your easy ho jata, this is 1.1 into 10 raised to 7 into 9, and these people 1 over 9 minus 0. So this is 1.1 into 10 to the power 7 into 9 times 1 by 9. This will go away. So what is 1 upon lambda? That is 1.1 into 10 raised to 7. So how much will lambda be? 1 over 1.1 into 10 raised to minus 7. I think you people can further solve this and give me the value not only in nanometers but also in angstrom. Thoda sa I'll further modify this. Also people, let's say ki instead of asking wavelength, what if they also ask you to calculate frequency? So what steps will we take? We know that C is equal to nu lambda. So can I say 1 upon lambda is nu over C, and 1 upon lambda is nu over, how much will we take C as people? 3 into 10 raised to 8. Therefore, lambda will be nu over 3 into 10 raised to 8, which will be 1 over 1.1 into 10 raised to minus 7. Can you solve this for me and also calculate frequency? Chalo. I did a small mistake here while substituting the value of 1 upon lambda. The value of 1 upon lambda I substituted as 10 raised to minus 7. So please वो correction देखना यहाँ पे ध्यान से. The approximate frequency should be somewhere around 3.3 into 10 raised to 15, and the approximate wavelength value we should get somewhere around is 990 angstrom. Chalo, let's go to the next one. For HE plus, calculate the wavelength of the second line. Now, in Lehman series, so they mentioned Lehman series. It is Lehman series. So what's the value of N1? Is 1. Now, how do you decide N2? Excellent. How do you get the first line in Lehman series? When it goes from 2 to 1. So for second line it is 3 to 1. Rest everything people remains the same. कुछ अलग नहीं है. Z का value since it is helium we'll take it as 2. RH is 1.1 into 10 raised to 7 meter inverse. Wave number का formula या wavelength is 1 upon lambda. अभी directly substitute करते हैं. So this will be 1.1 into 10 raised to 7 into helium is given, so 2 squared into 1 over 1 square minus 1 over 3 squared. You can compare your answer. So this is 4.4 times 8. 4 8s are 32. 4 8s are 32. Chalo, solve this for me. Give the answer in nanometers and also give me the answer in angstrom. Okay, so the answer of the previous question is somewhere around 26 nanometers or 260 angstrom. Let's go ahead with the next question. It says that heat treatment for muscular pain requires a radiation of wavelength 900 nanometers. So they have given us wavelength. कितना दिया है wavelength people? 900 nanometer. Which spectral line in hydrogen atom is suitable? So here it is opposite. We have to find N1 and N2 and they've given us the wavelength. And छोटा सा change है, they've asked Rydberg's constant का value RH to be used as 10 raised to 7 hydrogen atom है, so Z is equal to 1. चलो. So we know that 1 upon lambda is equal to RH Z square 1 upon N1 square minus 1 upon N2 square. So they've given us this is 1 upon 900 nanometers. So that will be 10 raised to minus 9 meters. The value for RH is given as 10 raised to 7 into 1 squared 1 upon N1 square minus 1 upon N2 square. So how much will that become people? 1 upon 900 into 10 raised to minus 9. ये 10 raised to minus 7 इधर आ गया. Sorry, 10 raised to 7 इधर आ गया. 1 upon N1 square minus 1 upon N2 square. This is 1 upon 900 into how much is this? 10 raised to minus 2 ये हो जाता है 1/9 is 1/n1 square minus 1/n2 square. Now this is where normal, see, you have two unknowns. दो unknown with one equation you cannot really find. तो यहाँ पे हम क्या करते हैं, just try and observe this people. ये थोड़ा सा अलग है. How can I write 9 as so that it looks similar to 1 upon something square? 9 को कैसे लिख सकते हैं हम? Correct. 1/3 square. Yes or no? Minus, can I say this is 0? Or 1/n1 square minus 1/n2 square, 1/3 square minus. I can write 0 as, excellent, 1/infinity. Did you get that? So what is n1 from here? 3. And what is n2 from here? Which series are we talking about? Fraction series. Did you people get that? ठीक है, चलो जल्दी जल्दी copy this for me, then we'll do some more sums. We have a homework question along with the hint written on the board. Students can try this at home. Chalo, the next question that we have is calculate the number of possible transitions from n2 is equal to 5 to n2 is equal to 1. What's the formula for number of spectral lines? Possible transitions, they are looking for number of spectral lines generated. What's the formula for number of spectral lines? n2 minus n1 into n2 minus n1 plus 1 over 2. So this is 5 minus 1 into 5 minus 1 plus 1 upon 2. I think ये आप लोग easily कर सकते हो. Quickly do this for me. Okay. So the next question that we have people is give a plot of wave number against 1 upon n square for n1 is equal to 1 and n2 is equal to n. So come on, give me the formula for wave number. Wave number is equal to 1 upon lambda. Since we don't need 1 upon lambda, इसलिए मैंने लिख रहा हूँ RH into z square 1 upon n1 squared minus 1 upon n2 square. यहाँ पे कर देते हैं for hydrogen atom, so that z will be 1. So क्या हो जाएगा people? Nu bar is equal to RH into 1 square 1 upon, how much is n1? 1 minus, and n2 we have to take it as n. Any questions still here? Bracket open कर दे. So wave number nu bar is RH into 1 upon 1 square will remain people 1, and this will become minus 1 upon n square. So wave number is RH minus 1 upon n square into RH. Any questions still here? Thoda sa we'll rearrange. Why? Because what do we want on the y-axis? Wave number against 1 upon n square. So people, 1 upon n square will be on the x-axis. So थोड़ा सा rearranging the equation. So nu bar is equal to minus 1 upon n square RH plus RH. Any questions still here? फिर क्या किया है? Now I will compare this with equation y is equal to mx plus c. Because on y axis, what did I want? Nu bar. X axis पे क्या चाहिए था people? 1 upon n square. So थोड़ा सा अलग लिखता हूँ मैं इसको. I'll write it as minus RH 1 upon n square. So what did we want on the x axis? 1 upon n square. So x axis is 1 upon n square. And what does C stand for? Excellent. This is y intercept. Now can we plot this? So x-axis we have 1 upon n square. Y-axis is wave number nu bar. Is the slope positive or negative? For a negative slope, how will the line look like? Very nice. The line will go something like this. Yes or no? And what is this? That is your y-intercept. And how much is y-intercept, people? RH. And how much is the slope? Minus we've taken it for n1 is equal to 1. You can have the same plot for any particular transition. ये हमने एक general ले लिया. But did you people get that? Yes or no? चलो. Quickly copy this for me. One homework question. Let's understand this. We'll also write the hint for this. क्या बोले? The value of n2 plus n1 and n2 square minus n1 square for HE plus are 4 and 8 respectively. So n2 plus n1 is 4 and n2 square minus n1 square is 8. They're not directly given as n1 and n2, but निकाल सकते हैं. Calculate wavelength of the emitted photon. So we have to calculate lambda. And they are saying that RH को क्या use करो? As 10 raised to 7 meters inverse. So what is the formula, people? 1 over lambda is RH. Z दिया नहीं है, so let us assume Z to be 1. 1 square. 1 upon n1 square minus 1 upon n2 square. So 1 by lambda will be RH. Can I write this as n2 square minus n1 square? I'm sorry. Oh, I'm so sorry. Pardon me. हाँ, helium दिया है. Sorry people. So ये हम क्या ले लेंगे? 2 upon n1 squared minus into n2 square. Let me tell you. Do we have a direct value available? इसका value they have directly given us. How much is that? 8. So 1 upon lambda is RH into 4 into 8. But do we have this like n1 square into n2 square? इसका value है क्या हमारे पास? This is one value that we have. But by any chance, can we use this and find n1 and n2? कैसे कर सकते हैं? Okay. How will you use this and this? थोड़ा सा सोचो. Can I say n2 minus n1 the whole square? इसका एक्सप्रेशन क्या होता है पीपल? n2 square plus n1 square minus 2n1 n2, yes or no? And what will be the expression for n2 plus n1 the whole square? n2 square plus n1 square plus 2n1 n2. Use this and thoda sa up with the given data you can find n1 and n2. Did you people get that? Chalo. So we stop here and next class we will start with photoelectric effect. सिर्फ आपको mathematical expressions use करने हैं and you can easily solve this.